Hello everyone and welcome to the lecture on Amazon Athena. So this lecture will contain all these topics. What is Amazon Athena? When to use Amazon Athena? When to use Amazon EMR? When to use Amazon Redshift? AWS service integrations with Athena. Understanding tables, databases and data catalogs in Athena. Tables in Athena. Table creation. AWS Glue data catalog and an example. So what is Amazon Athena? Amazon Athena is an interactive query service that allows users to analyze data directly on Amazon Simple Storage Service Amazon S3 without moving it. Athena uses standard SQL for data analysis, making it accessible to users familiar with SQL syntax. This allows for running ad hoc queries and getting results quickly. Athena integrates with Apache Spark, enabling users to run data analytics using Spark without managing infrastructure. Users can submit Spark code for processing and receiving results directly. With just a few actions in the AWS Management Console, users can point Athena at their data stored in Amazon S3 and start querying it. Amazon Athena console offers a simplified notebook experience for developing Apache Spark applications using Python or Athena notebook APIs. So this is slightly different feature. There are two features basically. You can have ad hoc queries. You can point to S3 and start querying, and then you have notebook experience also, through which you can start developing Apache Spark applications. So line by line, similar to Jupyter Notebook. Both Athena SQL and Apache Spark on Athena are serverless, eliminating the need to set up or manage infrastructure. Users only pay for the queries they run, making it a cost-effective solution for data analysis. Athena scales automatically, running queries in parallel. This ensures fast results even when dealing with large datasets and complex queries. So when to use Amazon Athena? So Athena supports unstructured, semi-structured and structured data in formats like CSV, JSON, Apache Parquet and Apache ORC for comprehensive analysis without data movement. You can run standard ANSI SQL query for quick insights without data aggregation or loading into another system. You can seamlessly integrate with Amazon QuickSight for easy data visualization, transforming query results into compelling visuals. You can connect with business intelligence tools and SQL clients via JDBC or ODBC drivers for detailed reports and data exploration. You can leverage AWS Glue data catalog. So integration with AWS Glue data catalog for a persistent meta store simplifies the data management and discovery across the AWS ecosystem. Perform fast interactive queries. So this, Athena is designed for speed and interactivity, enabling real-time data exploration and analysis directly on Amazon S3. Zero infrastructure management. Because Athena is serverless, and this serverless nature allows running interactive ad hoc SQL queries against S3 data without managing infrastructure or clusters. So this whole simplifies the analysis process. And pay only for queries you run. So it's a cost-effective pricing charges and users and cost-effective pricing charges only users for executed queries, and ideal for occasional and frequent data analysis tasks without maintaining dedicated analytics infrastructure. So when to use Amazon EMR? So there are two more services, EMR and Redshift, which are kind of confusing to beginners. So just to clarify when to use Amazon EMR. So Athena we have already learned in which situation to use Amazon Athena. Now let's see when to use Amazon EMR, which is Elastic MapReduce. So Amazon EMR simplifies running highly distributed processing frameworks such as Hadoop, Spark and Presto compared to on-premises deployments. This makes it ideal for organizations looking to leverage these powerful tools without the complexity of managing the infrastructure themselves. EMR offers a cost-effective solution for running large-scale data processing tasks. By utilizing cloud resources, it eliminates the need for significant upfront investment in hardware and ongoing maintenance costs associated with on-premises solutions. EMR allows you to run custom applications and code, and define specific compute, memory, storage, and application parameters. This flexibility enables you to optimize your analytic requirements precisely according to your needs, making it suitable for a wide range of data processing scenarios. Beyond SQL queries, EMR can handle a wide variety of scale-out data processing tasks. This includes applications for machine learning, graph analytics, data transformation, streaming data, and virtually any custom-coded data processing tasks. This versatility makes EMR a powerful tool for diverse data processing needs. EMR is particularly useful if you need to process and analyze extremely large datasets using the latest big data processing frameworks such as Spark, Hadoop, Presto, or HBase. It provides a managed environment for these frameworks. Amazon EMR gives you complete control over the configuration of your clusters and the software installed on them. This level of control allows you to fine-tune your environment to meet specific performance, security, or compliance requirements. EMR integrates seamlessly with Amazon Athena for querying processed data. Athena supports many of the same data formats as EMR and is compatible with Hive Metastore. This integration allows you to run DDL statements on Athena and query your EMR processed data immediately without affecting ongoing EMR jobs. And this provides flexible and powerful data analysis pipeline. So that was the EMR. So now we'll see another tool, Redshift, and when should we use Redshift. So Amazon Redshift is ideal for consolidating data from various sources such as inventory, financial, retail systems into a unified format for long-term storage. It is the preferred option for generating advanced business reports based on historical data. The query engine in Amazon Redshift excels in executing complex queries involving numerous large database tables, and opt for Amazon Redshift when querying highly structured data with extensive joins across large tables. So here the goal is long-term storage, and the goal is have to have massive data set, and the goal is to have like extensive joins with large table, and finally you generate some reports, and that's like long-term reports. So if those are your requirements, then you have to go with Amazon Redshift. Now let's see what service integrations are available with Athena. First one, Amazon AWS CloudFormation. So CloudFormation can be used to create Athena environments or Athena objects. Then have CloudFront. You can use Athena to query Amazon CloudFront logs. So sometimes, let's say CloudFormation is the source and target is Athena. Sometimes it's opposite, where the Athena is source and it will operating on some service. So in CloudFront, Athena can be used to query CloudFront logs. AWS CloudTrail. Use Athena with CloudTrail logs is a powerful way to enhance your analysis of AWS service activity. Amazon Data Zone. Use Amazon Data Zone to share, search, and discover data at scale across organizational boundaries. Simplifies experience across AWS analytics services like Athena, AWS Glue, and AWS Lake Formation. You can build business use cases based on groupings of people, data, and tools with large amounts of data in various sources. Elastic Load Balancing. Athena can query application load balancer logs, which allows you to see the source of traffic, latency, and bytes transferred to and from Elastic Load Balancing instances and backend applications. Amazon EMR. You can utilize Athena in EMR Studio for interactive query development, enabling SQL analytics on Athena within the EMR interface alongside Spark, Scala, and other workloads. AWS Glue. Athena integrates with AWS Glue Data Catalog, providing a metadata store for data in Amazon S3. This enables table creation and data querying in Athena using a central metadata store accessible across your AWS account. It is integrated with AWS Glue's ETL and data discovery features. AWS IAM Athena API actions can be used in IAM permission policies. Amazon QuickSight Athena integrates with Amazon QuickSight for data visualization, report generation, and data exploration with business intelligence tools or SQL clients via JDBC or ODBC driver. Amazon S3 inventory Amazon Athena enables querying Amazon S3 inventory using standard SQL for auditing and reporting on object replication and encryption status for business, compliance, and regulatory requirements. AWS Step Functions AWS Step Functions can manage Athena operations through Amazon States language, which allows query execution control, result retrieval, ad hoc or scheduled queries, and data lake interaction in Amazon S3. The step function role requires Athena permissions. AWS Systems Manager Inventory AWS Systems Manager Inventory collaborates with Amazon Athena for querying inventory data across multiple AWS regions and AWS accounts. Amazon VPC Amazon Virtual Private Cloud flow logs provide IP traffic details in VPC network interfaces. Athena analyze these logs, so you can analyze these logs in Athena to detect network traffic patterns, threats, and risk within your Amazon VPC network. So let's see some details about how the tables, database, and data catalogs are structured in Athena. So in Athena, catalogs, databases, and tables are containers for the metadata definition that define a schema for underlying source data. So at the highest level, we have the data source or the catalog, and under that it will be consisting of one or more databases, and every database can have its own more or one tables. So this is high level structuring. So Athena uses the following terms to refer to hierarchy of data objects. So we have seen data source, which is referred to as catalog, which is a group of databases. Also it can be called as a schema, which is a group of tables, and tables, which is database data organized as a group of rows and columns. Next is tables in Athena. For each dataset you want to query in Athena, a table must exist. The table metadata includes location of data in S3, structure of the data, which is the column names and data types, and a table name. So databases are logical grouping of tables and hold only metadata and schema information for a dataset. Next is creating tables. Before querying data, a table must be registered in Athena. This can be done automatically or manually. Automatic table creation. You can create a table automatically using an AWS Glue crawler. When AWS Glue creates a table, it registers in its own AWS Glue data catalog. So Glue crawler will go and find out tables in S3 data source, and it will create a table in Athena, but it will have the metadata about the table in the Glue data catalog. So Glue is a separate service. And manual table creation. To create a table manually, you can use Athena console to run the create table wizard. You can use Athena console to write Hive DDL statements in the query editor. So DDL is a data definition language. So create, update table are called as DDL statements. You can use Athena API or CLI to run query using the DDL statements. So you can use API or CLI, or use the Athena JDBC or ODBC driver, and all this will create manual. This is how we manually create a table. So when creating tables and database manually, Athena use HiveQL data definition language. Statements such as create table, create database, drop table under the hood to create tables and databases in the Glue data catalog. So this is some underlying information, like how it's implemented, because it's using Hive technology, Hive Metastore. So that's why underlying under the hood it will be running those statements. Even if you on the console, if you see create table, but under the hood it will be running the Hive DDL statements. Okay, AWS Glue data catalog. So Athena uses AWS Glue Data Catalog to store and retrieve metadata and use it when running queries to analyze the underlying dataset. In Athena Query Editor, this catalog or data source is referred to with label AWS Data Catalog. So Athena is tightly integrated with Glue Data Catalog. So it's the Glue Data Catalog that is the whole metadata base, and it has so at the highest level the name is called this catalog name is known as AWS Data Catalog, and inside that will have databases, tables, all this will be stored inside that Glue Data Catalog. So first it will do a metadata lookup and query optimization, and then a query execution from the S3 bucket or the raw data files. So querying data. So after creating a table, you can use SQL select statements to query the table, including getting specific file locations for your source data. Query results are stored in Amazon S3 in the specified query result location. So you use query editor in Athena and you run query against S3, and the results, whatever comes out, also gets stored back in S3 bucket. So that if you run the query second time, it will fetch from, if the query is exactly same, it can fetch from the results S3 bucket. Okay, this is how it looks like. So this is an example. So we start with catalog or the data source. So we can choose. So by default, the default name is AWS Data Catalog, which is the default name. So this name will definitely exist because it's the starting Hive Metastore catalog. Then you will choose a database. So default database will be there, and inside that you will see all the tables listed. You can click any of the tables and run your query. So in this example, I am running. So first I give a data catalog, then the database name and the table name. So there are 3-level hierarchy, and fetch all the results. And whatever results come out, it will show how much data is scanned, runtime, all those things. And finally, this results will also be stored in a S3 bucket so that it can be retrieved faster on the second run. And that's all. Thanks for watching.